Welcome to Robotics on the Rise, from labs to lunar landscapes. In this episode, we delve into breakthroughs from 17 recent robotics papers published at the end of 2025. We will explore how advances in perception, planning, and real-world deployment are driving the field forward. Join us as we highlight the pivotal paper of the day, tracing the journey from theoretical foundations to practical, robust machines poised to transform industries and daily life. In this guided tour of robotics frontiers, expect to discover how robots are learning to see, understand, and act in complex environments. We will trace dominant research themes and technical leaps that define the field today. Key findings shaping the next generation of robots will be explored, as well as seminal papers that are driving progress and setting new benchmarks. Finally, we will envision future directions and grand challenges that lie ahead for robotics research. Setting the stage, robotics exists at the intersection of computer science, engineering, and artificial intelligence. The field focuses on designing and building machines that can autonomously sense, plan, and act. Its impact extends from manufacturing and healthcare to rescue operations and space exploration. Research in robotics blends foundational theory with real-world applications, fueling innovation that stretches from advanced algorithms to lunar infrastructure. The discipline thus drives progress not only in software and hardware, but also in the integration of both. Theme 1 centers on the rise of multimodal intelligence in robots, particularly the integration of vision, language, and action. Recent work by Zhang and colleagues, as well as Vo and collaborators, has established robust benchmarks for multimodal systems. These advances enable robots to interpret everyday speech and complex visual scenes, moving beyond rote memorization toward genuine understanding. The challenge remains, achieving true generalization so robots can interact naturally and flexibly with people and their environments. Theme 2 addresses the challenge of mapping, sensing, and navigating real-world chaos. Robots are now expected to operate in dynamic, unpredictable environments such as hospital corridors, warehouses, and disaster zones. Zhang et al. Have contributed rapid, real-time mapping and path planning techniques, allowing robots to update their internal world models instantly. The ability to update on the fly is crucial for safety and operational effectiveness, enabling robots to adapt to constantly changing surroundings. Theme 3 focuses on simulation, robustness, and transfer learning. Befford et al. Advance the simulation of physical interactions, providing safe environments for testing robots before real-world deployment. Career et al. Demonstrate that robots can acquire tasks by observing humans, emphasizing the importance of robust adaptation to clutter and distractions. Modular, transferable skills are essential for flexible robots, and simulations that balance accuracy with computational speed are foundational for reliable real-world trials. Theme 4 highlights modular robots and specialized applications, exploring how modularity enables flexibility and resilience. Uno et al. Have engineered robots with interchangeable parts, suitable for complex lunar construction tasks. Such modular systems can adapt to varied and harsh environments, exemplified by robots designed for intubation, construction, and collective swarm behaviors. This approach drives unique innovations and addresses challenges specific to each application, furthering the versatility of robotic platforms. Key findings from recent research reveal both new capabilities and persistent challenges in robotics. Real-time simulation is now bridging the gap between theory and practice, as demonstrated by Befford et al. However, multimodal robots, according to Zhang et al., still struggle with true generalization. Career et al. Show that human-to-robot skill transfer can nearly double performance on novel tasks. Modular and object-centric designs, as seen in the work of Vo et al. and Uno et al., significantly boost robustness. Open benchmarks, especially those introduced by Zhang et al., are accelerating collaborative progress across the community. To understand how these advances are achieved, consider the methodologies shaping cutting-edge robotics research. Model predictive control allows robots to plan movements much like chess players, constantly evaluating future actions. Modular policy learning divides cognitive tasks among specialized modules, enhancing flexibility and reducing the risk of forgetting previously learned skills. Simulation provides safe, detailed virtual environments for testing before real-world deployment. Benchmarking through standardized tests reveals both strengths and weaknesses in robotic systems. Crucially, Modular learning is enabling robots to adapt without erasing prior knowledge. The paper of the day is VLA-Arena by Zhang et al. 2025, titled VLA-Arena, an open-source framework for benchmarking vision language action models. This paper introduces a systematic and reproducible evaluation platform for multimodal robots. With 170 tasks designed to probe safety, generalization, and robustness, VLA-Arena reveals that current models excel at memorization but falter at generalization. The framework sets a new open standard for the field, drawing parallels to the transformative impact of ImageNet in computer vision. A seminal study from Beffert et al. 2025 addresses real-time, safe drone operation through advanced modeling of UAV tether aerodynamics. Their paper, Modeling of UAV Tether Aerodynamics for Real-Time Simulation, presents both analytical and numerical models for simulating drone tethers. These approaches enable long-duration, real-time aerial missions by balancing computational speed with simulation accuracy. The result is a significant step forward in enabling persistent, robust UAV operations for tasks ranging from disaster response to industrial inspection. A major breakthrough in robust perception comes from Vo et al. 2025, with their work on clutter-resistant, object-centric robot models. Their paper, Clutter-Resistant Vision Language Action Models Through Object-Centric and Geometry Grounding, demonstrates the importance of separating perception from action for enhanced reliability. By employing object-centric and geometry-aware modules, their system outperforms traditional black box, end-to-end models in real-world settings. This approach is pivotal for developing safe and adaptable robots capable of thriving in complex, unpredictable environments. Looking ahead, the road for robotics research is shaped by several key directions. Tighter integration between data-driven learning and modular, explicit architectures is anticipated, blending the adaptability of large models with the reliability of specialized modules. Community-driven benchmarks will continue to drive fair and cumulative progress. Safety, ethics, and human-robot collaboration are becoming top priorities, especially as robots learn from increasingly diverse datasets. The overarching focus remains on enhancing reliability and adaptability for real-world applications. This deep dive episode was created through human-AI collaboration, synthesizing content with GPT-4.1 from OpenAI and Amazon TTS for narration. Visuals were conceptualized using Stable Diffusion, while content was reviewed by a human expert to ensure clarity and accuracy. References to all cited papers are included for transparency. Please note that, despite best efforts, minor oversights may remain. Thank you for joining us at AI Frontiers. Do not miss future episodes. Subscribe to AI Frontiers on YouTube to stay updated on the latest in AI and robotics research. Be part of our community of curious minds and innovators by leaving your questions or comments below each episode. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, complex research is simplified so you can stay ahead. Whether you are a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses R14.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by R14.org.